Hey YouTube, welcome to another video. In this episode, I will show how to create a bridge VLAN. A bridge VLAN is a special type of VLAN. This VLAN will have multiple VLAN IDs and they will reside in one IP network or subnet. This reminds me of RFC 3069 about Super VLAN and Sub VLAN, as well as Cisco's Community VLAN and Private VLAN implementation. However, I am not sure if this is exactly the same. Typically, each VLAN uses a different IP network, but Bridge VLAN shares an IP network across multiple VLAN IDs. Imagine having two or more VLANs in the same IP network of 192.168.10.0. This is particularly useful in an MDU or multi-dwelling units such as resorts, hotels, and apartments, where the system admin or the network engineer can provide an easy way of creating multiple dedicated and isolated VLANs. To visualize this, I have created a simple diagram and scenario. In this diagram, I have a building. So this is a building with 20 rooms. So room 1, room 2, up to room 20. And each room is occupied by a different tenant. Each tenant have their own network and devices inside their office can communicate with one another. For example, a phone can print to their office printer. However, there is no inter-tenant or inter-VLAN communication. Room 3 cannot communicate with room 4. Room 10 cannot communicate with room 9. While there are several ways to achieve this, there are a couple of solutions that may seem obvious but will not work. For example, creating a guest Wi-Fi will not work because each client in a guest Wi-Fi is isolated. As for creating ACLs, it can only work up to a certain point due to the ACL limitation. This is the controller specification sheets. This is page 5 of the controller OC200 and OC300, as well as software controller. So in here, you will see that the gateway or the router will only have a maximum ACL of 64. For the switch, you can only have 32 ACLs, and for the access points, you can only have 16 ACLs. Due to that limitation, using ACLs in MDUs with high number of rooms may pose a challenge. I would like to reiterate that bridge VLAN configuration is not a one-size-fits-all solution for the scenario, that there are other ways to achieve this. However, I just want to showcase this feature in this video. By the way, in this planned diagram, I wanted to point out a few things. Only one Omada gateway is required for this configuration. An OG ER605 version 1.0 will not work. So in this video, I will be using an ER7206. I have tested this on ER8411 and ER707-M2. Those work properly, and if you have a different gateway version, you will need to check their firmware for support. The number of switches and access points are not accurate representation. They will vary based on location and room configuration. In this diagram, you will see that I only have two IP networks, which is the admin and the bridge VLAN. But I will have more than 10 VLANs once the configuration is completed. Also, for the lab setup, I will have what I call staging VLAN. This is a wired-only VLAN and is not needed for actual bridge VLAN configuration. However, I needed this staging VLAN so I can demonstrate the functionality of the bridge VLAN. Having said that, let's jump into the Omada console. These are the devices that I have. As I mentioned, I'm using an ER7206 for my gateway. This is version 1.0 and you can see the firmware version in here. And I have several switches in here, SG2210MP, and I have one access point which is EAP235 wall. So the access point needs to support PPSK. In order for this configuration to work, you will need to check your access point and then respective firmware and software to see if they provide PPSK support. So far, these are the latest firmware versions that I have for these devices. As for the clients, you will see that I have several Raspberry Pis in here, as well as a couple of Windows machines. Those that resides in the 192.168.77 network, they are in the staging VLAN. And I'm only going to need that so that I can connect via VNC and I can demonstrate connecting to the wireless network. This staging VLAN is not really required in the bridge VLAN configuration. So for the LAN, I have the default VLAN IP of 192.168.0.1 for my gateway, and the 77-staging is just for me to show and demonstrate how bridge VLAN works. This is why I needed the staging VLAN, so that I can show you all my clients. So this is the client 101, client 102. So let me just debug it here. All of them are Raspberry Pis. It's just much easier for demonstration. And here you will see they have different wallpapers. So it's easy to identify. So this is 50, another 50 you can see also refreshes. And this one is actually my old machine, the one that has display if you're looking at the main screen. Okay, so these are all my clients in here in staging VLAN. Okay, so let's jump into the configuration. To configure this, you have to go to settings and then LAN, and then you will have to create new LAN. Let's call it 1XX first floor. So it must be an interface. I will have to select all of this, and in here the VLAN type must be multiple. You can see here how the information pop-up changes once I select multiple, and let's say here 2 to 20. I'm creating VLANs 2 to 20, and the IP network will be 192.168.10.1/24. Update TCP range, you can see here. And let's start with 101 just for consistency with all my other videos. You can see here from the screen it's already a little bit different because I created VLAN 2 to 20, but I only have one IP network because this is a shared IP network divided into multiple VLAN IDs. And then click save. There you go. So in here you will see a rare sighting of a bridge VLAN in your network. You cannot use this yet, not yet, for your wired clients, but if you stick around till the end, I will show how to use bridge VLAN with wired clients, as well as how to create an ACL to secure your network. But for now, let's use bridge VLAN for our wireless clients with PPSK. I will only create a few profiles for demonstration purposes. So settings, and then PPSK, and then I will create a new PPSK profile. I will just call it first floor. Use, and then click add. In this video I will choose auto, but in your situation feel free to use whichever works best for you. I will select auto. In this video I only have 9 clients, so let's make it an even 10. PPSK name prefix, I'll just say room 1 dash, and then for the passphrase length I will put 8. For the VLAN assignment, it needs to be reflecting the VLANs 2 to 20. I will just leave it blank, and then I will just edit once it's generated, so it's much easier for me to do that. So click apply, and there you go. To shorten the video, I will edit all of these PPSK profiles offline, then show the completed version afterwards. And you can see all the passphrase in here. So this is the automatically generated passphrase. So I'll click apply, and there you go. They have the first floor MDU's PPSK profile. I will now create a wireless LAN to use these profiles. So I will need to go to settings, and then wireless LAN, and then I need to create the wireless network for that. So create network. So the wireless network will be MDU Wi-Fi. The device type will be EAP, and I will select 2.4 and 5 gigahertz. And don't select guest network. In here, select PPSK without radius, and under PPSK profile you need to select the one that we created, first floor MDUs, and then click apply. There you go. That's pretty much it for the configuration. Let's now move on to the testing. I have my 9 clients up and running here, so let me just connect them to the respective VLAN. All of these 9 clients I will connect to rooms 2 and onwards, and this is my IP. As you can see, I'm residing at the default VLAN 192.168.0.103, and I can actually ping all of these. I'm just going to the motion of pinging all the clients in here. There you go. And as you can see, I can ping them without any issues. So now I can connect them to their respective PPSK. So the first one will be room 2. So I will need this. I copied that one, and let's just go to this one, and let's turn on the Wi-Fi or networks, MDU Wi-Fi, and the password will be paste. There you go. Connect. And you can see here that the IP address that it got is 192.168.10.101. I will do the same for all the rest of the clients. I will speed up the video. And there you go. I'm connected to all of them except the admin VLAN. For better demonstration, an additional profile is needed. So let me just create another one. I will use this computer, this admin PC, as another client to show the isolation. I click apply. So I just created an additional PPSK profile, which is for VLAN 11, so that I can further demonstrate the separation and isolation of each VLAN. And here, copy this. This profile is specifically for my admin PC. MDU Wi-Fi, connect. So just verifying. Next. There you go, it's connected. Let's check it out. My IP is 192.168.10.110. So now it belongs to the same IP network as my Raspberry Pi. So if I go to clients, and I'm just going to filter for all the wireless clients, and let's sort by IP address. And you can see that all wireless clients are in the 192.168.10 network. This is the bridge VLAN. But all of these clients are all residing in different VLANs. VLAN 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Earlier, I have shown you that I am connected to these clients via the staging VLAN. So let's just revisit that again. So in here, 77.101. And this one, 77.105. I'm just randomly checking, just making sure that I'm still connected. I can connect to all of them via the staging VLAN. And now what I'm going to do is to disable the staging VLAN completely on the switch profile. So let me go to devices, and let's go to AS01, go to ports. Let's see this one. I'll disable this. Disable. And there you go, it's disabled. Let me go to AS02 switch. I'm going to do the same thing. I will just select all of these. All stage are selected, and break the connection. Disable, apply, and there you go. It's all disabled. So now if I go here, I will not be able to connect to them. There you go. I cannot connect them via their IP address anymore. If I go here, earlier I was able to ping all of them, so I'll just speed up the video. I'll just let it go through and speed up, and I'll just go to all the networks in the VLAN. So this is the last one, 109. As you can see, it finished pinging the set. So I'll just go back here. Currently, I'm still connected to my wired Ethernet, and I'm connected to my MDU Wi-Fi as well. So let me just disable this. I will still have internet. Go. And as you can see, it's currently disabled. And I'm connected to the internet via the MDU Wi-Fi. This one. Let me just go to the controllers and go to the clients again. And let's see all the IP addresses of the clients. Let me see. There you go. Now it's sorted via IP address. 101, 102, 103, 104, 105, 106, 107, 108, 109, 110. Each of these clients are in their respective VLAN, and each of these clients will not be able to see each other. And I can demonstrate that using my admin PC. Let me ping the 101 first. Ping 192.168.10.101. Since this admin PC is in VLAN 11, I cannot reach the 101. Same thing for 102. Same thing for 103. Same thing for 104. The same thing for 105. The same thing for 106. Go. 107. 108. And 109. But of course, I can ping myself. There you go, I can ping myself. Right. Now I will demonstrate multiple computers being in the same VLAN. So they will be in the same IP network as well as in the same VLAN. So I will connect to VLAN 2 using my admin PC. That means I will need to use the room 2 PPSK so that I will be able to join the VLAN 2 IP network. Let's do that. So let me duplicate this. And then go to settings. Then go to PPSK. I will still have the same IP network of .10. However, I will be in VLAN 2 because I will be using this PPSK, this passphrase account. So let me copy this. Let me forget. And you can see here, that's my account. Click next, click yes. I'm connected, and now I will be in the same VLAN as this user. That means VLAN 2. If I refresh this, then go to wireless, VLAN is it still shows VLAN 11 for my media PC. I guess it hasn't reflected yet, but let's try pinging the IP address. Earlier, when I ping 10.101, I have a failure, so let's see. There you go. This is the first ping that I did, 101. So let's try that again, 101. And now you can see that it's replying. When you will see that I still have the same IP address of 110, 10.110. And I will be able to connect via VNC to this particular workstation. So let's connect there. 192.168.10.101. And from here, let's demonstrate. So ping 192.168.10.110. So I'm pinging my admin PC. It should be successful. But I will not be able to ping 102. Same thing, 103. So I will not be able to ping that. I will keep this running, but this time around, I will connect to a different PPSK. Let's select room 9, which is VLAN 9. So let's connect this one. And this will be the final demo for this one. Forget. So I forgot that one. Let me refresh it. MDU Wi-Fi connect. Control V, and let's verify. E8. EAE, okay. Click next, click yes. And now I will be in VLAN 9. So what will happen is that this one will get disconnected. There you go, I'm connected. And let's go to the VNC. So since this one is now in a different VLAN, you can see that I cannot click anything. And later on, it will get disconnected. So let me go to the clients again. So now I should be in VLAN 9. There you go. This reflects my VLAN now. So I can see 108. So let's check that one out. Ping 108. There you go. I can ping 108. And as you can see here, it's now currently disconnected. And that's because I'm in a different VLAN. So let me connect to 108. And of course, in here I can ping 110, which is my admin PC. So it's taken a while for it to launch because this is a very slow machine. It's a Pi 0. So once it launches, it should be fine. So you can see I can ping my admin PC, which makes sense. But I will not be able 103 to reach all the other computers in a different VLAN. So that's how it works. So we just finished the wireless and PPSK portion of the configuration for the bridge VLAN. The next configuration and demonstration that I'm going to show is a bridge VLAN for the wired network. I'm not sure if this is an intended use case by TPLINK because I haven't seen any documents that discussed about bridge VLAN for the wired network. So this is something that you will see only on my channel, and I haven't seen it anywhere on any YouTube channels or from any documentations or from any content creators. And you will see more what I mean as we go through the configuration. So having said that, let me show you how to configure a bridge VLAN for wired networks. Configuring bridge VLAN for wired networks is not straightforward because there is no access port switch profile for the bridge VLAN. What do I mean by that? So if I go to settings and then LAN, so in here you will see all the 3 VLAN interfaces that I have currently on my setup. The first one is the default VLAN interface. The second one is the bridge VLAN interface. And the third one is the staging VLAN interface that I have for demonstration purposes. Normally, a VLAN interface will have an associated switch profile. However, in this particular case, there will be no switch profile assigned for the bridge VLAN. Let me go to switch profile. And as you can see here, I only have the admin VLAN and the staging VLAN as my switch profile. If your profile is not listed in here, it cannot be assigned to a switch port. So let me show you what I mean. So devices, And then I'll select one of the switch, go to ports, and then if I click here, port 3, currently the profile is all. If I click edit, I don't see any profile for the bridge VLAN interface. I only see the admin and the staging VLAN interfaces. So that means I cannot have a wired version of the bridge VLAN. There is a workaround for that, and this is the reason why I said this might not be an intended use for this particular feature. Go to manage profiles, and what we can do is create a profile specifically for a VLAN ID for one of the bridge VLAN. Click create new port profile, call it 02 VLAN 2 and call it bridge, and in here you will have to select one of the bridge VLANs. Once I highlighted this one, you can see the VLAN ID of the bridge VLAN. So this one is 2, this one is 3, so on and so forth. So I will select here 2, there you go, and you can see here that I will have an untagged network of VLAN ID 2 for the bridge VLAN, and I'll create another one just for demonstration purposes. But you can see here a switch profile is now created with the native network of VLAN ID 2, which means that this can be assigned to a switch port as an access port. So I'll create another one, and then I'll click save. Now that I have these switch profiles, I will be able to use them as my access port switch profile for my switch. And let's go to AS01. This is the switch where my admin PC is currently connected. It is currently connected at port 5. So if I go here and check my IP, I have an IP of 192.168.0.103 because this is an admin VLAN. So I'll click close. So what I'm going to do next is change the profile of port 5 into one of the bridge VLAN access port that we created earlier. So I'll click here edit, and in here I will select 02-bridge, and then I'll click apply. I need to disable and enable my network card so that I will get a new IP. So disable and then enable. I should get an IP address from the 192.168.10 IP network, but I should be in VLAN 2. So double click that one, and then click details, and there you go. You can see that my IP address is 192.168.10.111. My Wi-Fi used to have 192.168.10.110, but since this is a wired network interface, it got a new IP address assigned to it. Let me close that, and let me disable my Wi-Fi. There you go. And let me go to clients, and let me go to wireless, and let me sort it by VLAN. So now I can do some testing and ping the IP address of this particular machine in here that is in the same VLAN as my PC, which is VLAN 2. So I'm going to ping 192.168.10.101, and it should reply. Ping 192.168.10.101, and this one should reply. However, since I'm only in VLAN 2, I should not be able to ping all the other VLAN IPs. So 102 will not work, 103, 104, 105, 106, 107, 108, 109, and even my Wi-Fi IP will not work because I have disabled that interface. So now I have a wired connectivity for my bridge VLAN. Let me demonstrate another one, which is the 09-B bridge. So now I'm going to change the port 5 into 09-B bridge so that I will be able to ping Pi0W, which is in VLAN 9. So let me edit this one, select this, and click apply. Again, I need to disable and re-enable. I just want to make sure that the VLAN tagging will be correct. So now I'm in VLAN 9, but I will still have the same IP address because this is the same IP network. If I click details, you will see that I'm still using 192.168.10.111. So let's check that. So earlier I was able to ping 101, but now I will not be able to ping 101 until 107, but I will be able to ping 108. So let's do that. 101, it's not working anymore, so I'll move on to the other one. 102 is not working, 103 is not working. 104 is not working. 105 is not working. 106 will not work. 107 will not work. However, 108 should work because this is in the same VLAN, VLAN 9. And there you go, it's working. But of course, 109 will not work, and 1110 will not work. And now you can see that the bridge VLAN is now working. The wired bridge VLAN is not so straightforward. You have to create a dedicated switch profile, and like I said earlier, I am not sure if this is an intended use case, so be very wary and be careful when using this. If it's not an intended use case, then it can be turned off or removed at any time. So as an additional test, let me connect to this device via VNC 192.168.10.108. There you go, I'm connected. So now my next step will be to show you how to configure an ACL using the bridge VLAN. By the way, even if I create an ACL, since my controller is in my private cloud, I will always have access to this as long as I have an internet access. And that's the reason why I use a separate machine for simulating another device in the management VLAN. So let me go to wired. And you can see here my Samsung laptop is 192.168.0.104 that resides in the local area network. So let me ping that one. Ping 192.168.0.104. As you can see, I can reach this particular network without any issues from the bridge VLAN. And let's use another one as ping 192.168.0.104, and you can see that I can reach it. If you would like to limit the access of the bridge VLAN to the admin network, what we can do is create an ACL in the gateway level. So let me do that. Go to settings and then ACL. So let me hide this for the time being. Create new rule. Let's call it deny bridge VLAN. Make sure this is enabled, and destination will be LAN to LAN. There you go. Protocols will be all, and then I will select network here, and I will select the bridge VLAN that we created earlier, which is this one. There you go. And then network, and then admin, and then click create. There you go, we have created an ACL to deny all of the bridge VLAN, which are VLANs 2 to 20, from accessing the admin VLAN. Let's test that. So this ACL is stateful, so just be careful with it. Ping 192.168.0.104. So earlier you can see that we can ping a device that is residing in the admin VLAN. So with the new ACL, we should not be able to ping it. I'll click enter. You can see that I'm not able to ping it anymore. What I'm going to do is test my admin PC, this admin PC, and see if I lose connectivity to the 192.168.0 network as well. So you can see here earlier I was able to ping the 192.168.0.104, and let's try now. And you can see it doesn't work as well. Same thing here. Okay, so I think that's pretty much it for the configuration. I have demonstrated the bridge VLAN configuration for both wired and wireless connection. I want to emphasize that for the wireless connectivity, you don't really have to use PPSK. You can just hard code the VLAN IDs on each SSIDs. As for the wired connectivity, I also would like to emphasize that I haven't seen any configuration from TP-LINK regarding the wired bridge VLAN configuration. So this might not be an intended use case. So just be careful when you're using that in production environment. Okay, so I think that's pretty much it for the video. I hope you like this video. If you like this video, please give it a like. If you don't like this video, please give it a dislike. But do let me know what you don't like in this video so that I can make those future changes. It took me a really long time to make this video, so I hope you appreciate it or at least get something out of it. And I hope if I haven't earned your like or subscribe, I hope that this video will make you do that. Thank you again for watching my video. I'll see you on the next one. Thank you and bye bye.